the building industry is a really interesting one where we could have traditionally static materials become highly active and dynamic. All of our buildings use mechanical means to mediate the environment. We use expensive and complex thermostats and HVAC systems and electrical systems to control the inside to outside, but we could have much more living or transformative materials that actively mediate that environment. So depending on sunlight, depending on moisture, humidity levels, sound. If you think about acoustics, there's a really interesting one. Acoustic panels are static, but the acoustics in the room is completely dynamic. So your acoustic panels could adapt to the noise levels in the room to help amplify the noise or to help dampen the noise. Same with sunlight, same with moisture, temperature control. We try to look at external domains where other systems and other phenomenon have similar properties and try to translate those. Look at what materials, what energy sources, and what mechanisms we can utilize at the human and larger scale, at macro scales. We collaborate a lot with biologists, chemists, material scientists, and we're extremely interested in phenomenon outside of the human scale and how other systems can adapt, replicate, reconfigure, transform, etc., and look at how we can translate those to larger scales. But it's not just biology. We're interested in non-natural, non-living systems. We're interested in very large systems like astronomy or population movement or magnetics. We're interested in crystals. We're interested in biology as well. So I think there's lots and lots of phenomenon, and what we're interested in is trying to rethink the human industrial scale. Because at every other scale outside of the human scale, bottom-up systems collaborate to produce higher orders. At the human and industrial scale, everything is top-down. And so we're interested in rethinking our systems of manufacturing and construction to work in a bottom-up fashion. The first category of research that we do at the lab is self-assembly and self-organization. And this is a phenomenon where independent components come together to build a final structure completely on their own. And you see that in biology and chemistry, and actually the latest advances in material science are directed self-assembly to form new material properties. And what we're trying to propose is that you can use these processes of self-assembly for large-scale applications like manufacturing or like construction at many large scales where it's difficult to construct or difficult to build things, whether that's environmental constraints, that's budget constraints, or tolerance constraints. There's challenges where particles could assemble themselves without human or machine involvement. If you think about space construction, if you think about astronauts trying to build things, this is an example of a harsh environment where it's difficult to construct, where we have constraints on volume, constraints on weight, and what we really want is components to assemble themselves or to collaborate with humans to assemble a better structure than we could. But that's also the same as very small scales, or harsh environments, or disaster relief scenarios. It's a really interesting scenario where materials can have information and help you assemble structures. So most of our industrial processes today at the human scale, like construction and manufacturing, are predominantly top-down and brute force in the sense that we take raw materials, we force them by slamming them, by cutting away at them, we force them into shape, into designs that we've come up with. And we over-engineer systems to fight different forces and environmental constraints. And what we're interested in doing is collaborating with materials to let solutions emerge, so it becomes a new design process. So we may not know the best solution for a chair or a building or a bracket for a plane, but we can subject particles to forces and let them assemble themselves into a solution, but also to resist the notion that we're going to fight and force materials into place, but rather let them comfortably come together in the ways that they want to.